All right, let's get into it. Today, we're talking about a tool that is an absolute game changer for anyone working with Docker, Docker Compose. We're going to see how it takes you from that command line headache we all know to having total control with just one command.
I mean, just look at this. On the left, you've got the old way. It's a total mess, right? A bunch of long, complicated commands you have to type perfectly every single time. It's so easy to mess up. And then, look at the right. One command. That's it. This single image perfectly captures the promise of Docker Compose, taking all that manual chaos and making it simple.
Now, to really understand why Docker Compose is so great, we have to talk about the pain. We need to go back and look at what it's actually like to manage Docker containers by hand.
So this manual method has a name. It's called the imperative approach. Think of it like you're giving someone driving directions, turn by turn. You have to spell out every single step. You're telling Docker exactly how to build the image, how to run the container, what flags to use. You're responsible for everything.
And this is where it all goes wrong. This is the classic, it works on my machine problem. When every developer is typing their own commands, little differences start to creep in. Maybe one dev names the image my image, but another one calls it Ammon image. One person runs it on port 8080, another on 8081. And suddenly you're chasing down bugs that only exist because your environments aren't identical. That's not just annoying, that's hours of wasted time.
So, what's the fix? Well, the solution isn't just a new command. It's a whole new way of thinking. We have to stop telling the computer how to do things and start telling it what we want the end result to be.
And that brings us to the declarative approach. This time, instead of giving those turn-by-turn directions, you're just putting the final destination into your GPS. You just declare what you want. Hey, I want a container built from this code running on this port. You let the system figure out the how. You just focus on the what.
So what does this GPS destination look like in our world? It's a blueprint, a single, standardized file that acts as the single source of truth for our entire application setup. Anyone on the team can grab this one file and spin up an identical environment every single time.
And this is where Docker Compose finally comes into the picture. It's the tool that takes our declarative blueprint, a file that's usually just called compose YAML, and brings it to life.
Now, these compose files use a format called YAML. And just look at the difference here. On the left, you have JSON with all its curly braces, quotes, and commas. On the right, you have YAML. It's so much cleaner, so much more readable for us humans. There's no extra noise. The structure is just defined by indentation. It's honestly a joy to work with.
Let's quickly break down a super simple compose.yaml file. It's not as complicated as it might seem. At the very top, you have services. Think of this as the main bucket for all your containers. Then, indented underneath, you give your first service a name. We're calling it API here. Under that, we tell it how to build the image, basically just pointing it to our Docker file. And finally, we declare the ports we want to map. See how the indentation creates that clear structure? It's that simple.
Okay, so we've written our blueprint. We've declared our services, our builds, our ports. Now for the really good part. How do we make this all go? This is the big question, isn't it? We have this nice, clean file, our single source of truth. How do we actually turn this text file into a fully running application?
With this Docker Compose up, that is it. That one little command reads your file, builds your images if they need to be built, creates a private network so your containers can talk to each other, and starts everything up. It is seriously like magic.
You know, there's a great analogy for this. Running Docker Compose up is like ordering a pizza. You just ask for the pizza, but it automatically shows up with things like napkins or maybe some dipping sauce. You didn't ask for them, but they're included. And the Docker Compose config command, that's like peeking into the box to see all those free extras, like the default network Compose set up for you automatically.
And Compose makes the entire development lifecycle so much easier. You use Docker Compose up to get it all running. You can use Docker Compose PS to check the status of your services. And when you're done for the day, Docker Compose down. It cleans everything up, the containers, the network, the whole shebang. No more hunting for container IDs to shut them down.
Okay, let's talk about a real-world scenario. You're a developer. You're in the zone. You're writing code, and you make a change. What happens now? So let's say your app displays the text class Monday. You dive into your code editor, change that string to class Wednesday, hit save, and then you go back to your terminal and run Docker Compose up again.
So, what do you think?
You changed the code on your computer, you restarted the service. Are you going to see that update in your browser?
The answer, which surprises a lot of people at first, is no. Your change won't be there.
And here's the aha moment. It all comes down to a really important concept in Docker. Images are immutable. That means once an image is built, it's set in stone. It cannot be changed. So when you ran up the first time, Docker built an image with the Monday code. The second time, Compose saw that image already existed and just reused it to save time. Your Wednesday code is sitting on your machine, but it never made it into that old sealed image.
So, what's the fix? It's beautifully simple. You just add one little flag to your command, -build. This is you telling Docker Compose, hey, ignore the old image. I need you to rebuild it from scratch before you start everything. That forces it to copy over your new Wednesday code, create a brand new image, and then start a container from it. And just like that, your change appears.
So we've seen how powerful this is for just one service, but that leaves us with a final thought to chew on. What if you had a more complex application? With a front end, an API, and a database? How could you use Docker Compose to define and manage all of those moving parts from just one single file? That's where its true power really shines.